Hello everyone, welcome to today's lesson on factoring common factors. Right, so now this is where we get to the point where we're working with division. Right, there's going to be a lot of division here with polynomials because as mathematicians, we don't like working with big numbers, right? We want to simplify as much as we can, just so it's easy to calculate and clean to look at. So we still use a factor tree here. Let's take the polynomial 6n plus 9. Right? What's a factor that can divide into both of those terms? Right? A factor of 3, 6, and 9 is 3, right? And when we divide that, we can see that 6n plus 9 divided by 3 is 2n plus 3. Right? So remember, right, this means that the greatest common factor of 6 and 9 is 3. Right? And we can confirm that we cannot divide this any further. Right? Because we got a prime number here, 3 that's prime number, and 2 and 3, all prime numbers. So we cannot divide any further. Right? And also remember that when we divide a polynomial, right, by a single number, we're essentially just splitting it up because we have a plus sign at the top. Right? We're just splitting it up. And this gets us 2n plus 3. So now putting this all together, let me scooch all this aside here. Okay, putting all this together now, 2n plus 9 can be factored into 3 times 2n plus 3. Okay, and that's it. That's how we factor something using common factors. Right, both of those terms can be divided by 3 to get 2n plus 3. So this is just 3 times this bracket. We can double check this. Right, if we do our flying arrows to double check, 3 times 2n is 6n, 3 times 3 is 9, right? Okay, let's try a few examples. 4a plus 2. What can we divide both those terms by? Right, we can divide both terms by 2. So we get 4a divided by 2 is 2a, 2 divided by 2 is 1. Okay, just like that. Have the greatest common factor here. So once again, we know we can divide both by 2. But we also notice here that both of those, right, have a power of b. That's b to the power 2 and b to the power 1. Which means that we can actually divide a b out of both of those as well. Right, so we can divide out of 2b. 4b squared minus divided by 2b is 2b. 2b divided by 2b is 1. Right, so not only can we take out the factors, we can also take out variables as well. Right, we can clearly see in this example. So what's a factor that can divide into all of those? 12, 16, 36. Of course, actually here, we can do 2 first. Right? Oh, actually, no, sorry. Let's do 4, right? We know they can all be divided by 4. And also we know that the most amount of powers of c we can take away is 5. Right? Because we can if we do c to the power 6, yeah, this will become c to the power 4, thus c to the power of 3. But this becomes c to the power of negative 1, which we don't want. So the highest power we can take away is c to the power 5. Alright? 12c to the power 10 divided by 4c to the power 5. 3c5. Right, and then this divided by this. 4 and then c to the power 4. This divided by this. Alright? Minus 9. That's it. Alright? But sometimes it's not that obvious that's divisible by 4. Right? Sometimes we see that, oh, it's divisible by 2. Right? Which is correct. Right? So alternatively, we can also take out a 2c to the power 5. right? This is equally valid, right? Because we see, oh yeah, all those coefficients here, they're all even. So it's divisible by 2. But we notice here that, once again though, right, all those coefficients are still even. So we have to keep going until we cannot divide any further, right? Just like a factor tree. We want to keep going until either everything's prime, or we can no longer divide everything nicely. So here, we can still divide everything by 2. Alright, so that's why we will take out another 2. Right, to get us 4c to the power 5 at the front. Okay, so important here, right? We notice here that, okay, well, 4 and 9 are not primes, right? And 3 and 9, they're both divisible by 3, but it is not divisible by 4. So which means that we still cannot take anything out, right? If we want to take out a 3, if we want to divide everything by 3, we have to make sure every single term is divisible by 3. If we can't, then we just leave it, and that's the most simplified we can go. Okay, how about here? Once again, we can divide everything by 4. We also notice here that we have 2 variables. The most amount of e we can divide, or the most amount of d we can divide, is only to the power of 1. Okay? That's to the power of 3, power of 2, and power of 1. So at most, we can take out a d to the power of 1. Right? Same as e. Even though both of those here are e squared, we can only take out 1 power of e, because the first term is e to the power of 1. Take that out. 3d squared, 5e, and then 4de. Okay, just like that. Okay, negatives. Do we take out negatives? Yes, we do. Right, so I take out a negative 5f. Right, always try to take out a negative if you can. Or at least for the first term, right? If the first term starts with a negative, we want to take out a negative. Right, the first term usually you want to make sure it's positive. That's why you take out a negative 5 instead of positive 5. So we are left with this right here. And with any of those questions, you can always do the following arrows and expand it back to double check. Okay, once again, we know it's a negative something because the first term is negative. We don't want that. We can take out a 5 out of everything. Right? We can see here that the lowest power is to the power of 1 for g and h. So that's the highest we can take out. That's 3 g cubed plus, right? Remember, we're taking out negatives. So flip the signs. So let's be careful here, right? Negative 5f cubed divided by negative 5f is positive f squared. Minus 20f squared divided by negative 5f, positive 4f. Positive 10f divided by negative 5f is minus 2, right? Remember the negative signs. How about here? Right, so here's something interesting here. We notice here that both of those have a common factor still, because both of those are multiplying into I plus 1. So what we could do here in cases like this is take out the I plus 1. Right? Just like how here, right, the greatest common factor is 2. Down here, the greatest common factor is actually I plus 1. Right? Both of those terms are multiplying by I plus 1. So we can just take that out. And we are left with just the 3i here and then this plus 7 here. Right, so yes, we can take out brackets as well. How about here? Unfortunately, we have to rearrange it now, right? j minus 3 is not the same thing as 3 minus j. So what we could do here is to say, okay, our greatest common factor has to be j minus 3. So what we can do here is rearrange it so that it's j minus 3 instead. Right, and then of course, that's illegal, right? We cannot just, those two are not the same thing, right? Because if we swap those two things right here, we have minus j plus 3. Right, because again, it's 3 minus j. The 3 here is positive. Minus j, of course, is negative. So now how can we make everything j minus 3? Right, we need this to be j minus 3 to be able to factor it out. So what we could do here is multiply everything by negative 1. Right, because if we multiply this by negative 1, the signs get flipped. Right, this times negative 1 is positive j. 3 times negative 1 is negative 3. And of course, if we multiply everything by negative 1, we gotta do it to the front as well. So this actually becomes minus 9j minus 3. Now we factor it out. Yeah, there we go. And yes, this is extending / proficient level stuff. Right? But here's how we can manipulate polynomials. Right? Always make sure negatives. Right? Negatives will always trip you up. They'll always trip me up. Okay? Next is grouping. Right? Whenever we have 4 or more terms, we can try to group them together. Right? Because what do we do here? Right? How can we factor this? We cannot factor out a k, right? Because not every single term here have a k. Right? We do not have a k here on a 3. But what we can do instead, though, is put them to clumps. Right? Let's put them to brackets and put them to clumps. Okay. So now, let's work with clumps directly. Right? Just within our first clump, we can see that both of those can be divided by k squared. And the clump back here can be divided by 3. Alright, so then we can take out the k squared for the first clump and take out a 3 for the second clump. Hey, just like that, right? Now we can finally do what we did earlier. Right, so now both of those terms have a k plus 1, which means that we can factor that out with k squared plus 3 remaining. Okay, and that's it. So that's what we mean by grouping. Right, we can always put terms into groups of 2, take out the greatest common factor for those 2 terms, and then group factor out the bracket altogether at the very end. Right, it takes some time getting used to. Like, you have to actually spot the patterns here, right? But that's what practicing is for, right? I'll try another one. Put them into clumps. For the first one, right, we can take out a 2 and a L squared, right? That's the highest power of L, or lowest power of L. And this one, there's actually nothing we can take out, right? The greatest common factor is just 1. So again, for the first one, we take out 2L squared, giving us L by itself, minus 3. And the second term just stays, right? It's just, we cannot really do anything to it. But conveniently, we can now factor out the L minus 3. I gotta start avoiding using L's for my variables. This kinda sucks too, huh? Alright, there's a lot of variables in math that kinda sucks for variables. Like just the S, the L, O is the worst one, of course. Okay. Again, we group everything. But oh, would you look at that? What do we have here? Alright, now we got negative signs. Alright, and now if we look here, if we put this into brackets like so, right, this is something else completely different. Right, because when we take the brackets back out again, right, we'll get minus 2n plus 2n. Right, so we have to make sure that we flip the signs when we put it into brackets. Right, because when we take out the brackets again, right, we flip the signs and it goes back to the original question. Right, so be very careful here. It's always the negative signs. Right. If you ever got an incorrect answer, just look at your negative signs first. Chances are that's where the common mistake is. Anyways, you can factor out an m, factor out a 2. M plus n. Oh, very convenient. Alright, we can factor m plus n out. This looks super tedious, but this is actually a skill we need to learn for our next few lessons. And grouping. And besides, grouping is actually pretty convenient. Right, instead of needing to find a common factor of all this, we can clump them together and makes the grouping easier. Here's the last one though. Here's another big area minus small area kind of question. Right, to find the area here, do the big area subtracting by small area. Of course, remember our formula. Area of a circle is just pi r squared, r being the radius. Okay, so let's find the big guy first. Alright, the radius here is r plus 2. So pi times r plus 2. Yeah, of course, we expand it like we learned in the last lesson. Flying arrows. So r times r is r squared, right? R times 2. R times 2. And 2 times 2. Combine like terms. Okay, and then lastly, expand it, right? Pi multiplied by everything here. Okay, so that's a big area. Now for the small area, nice and easy, it's just pi r squared, right? The radius here is literally just r, so pi r squared. Now, for the final answer, area big minus area small. Minus area small. If we can see here, pi r squared, and then we have a minus pi r squared. So those two can just cancel out to get 0, right? This subtracts to each other 0. And remember our question, we want to be factored form. This is not factored yet. We can take out a 4, right? What else can we take out? Right, we can also take out the pi. Right, it's both of those are multiplying pi, so we can take that one out as well. To get us 4 pi r plus 1. Okay, and that's it. That's our question. That's our answer. Whew, okay, so with common factors, we want to look for the greatest common factor first for the coefficients. And for the variables, right, we are pretty much looking at what's the biggest power we can divide both of those by. So generally, we look at the smallest power in our question, and that's what we can take out. Because I have to make sure this power is divisible by everything inside. And then with grouping, we grouped them into 2 groups. That's a lot of groups I just said. Right, and then we take out the greatest common factor separately. And lastly, we can take out greatest common factor of the brackets as well. Okay, so that's pretty much just it for our first part of division with polynomials. There's gonna be a lot of those, so you might get sick of it soon, but that's okay. But with that being said, good luck practicing.